Hello, welcome back. This is Frederick from Tech Nordic. Today I'm going to talk a little bit about Keithley instruments like the DMM and the DAQ6510 here. And just again say that, we bought Keithley, Tektronix bought Keithley a few years ago and it's been a great success. So today's video, I will run through a presentation and afterwards I will, hook up one of the DAQ6510. I will install the scanner card and I will connect it to my PC and I will run a really great software called Kickstart, and it's some of the things you can do that. And I will also test my remote controlled car and see, like the power consumption and see how good they are in reality. So let's kick this off. So first of all, they are new products, yes, but it's actually more or less of a replacement. So the people have 2000 scan. They should now move over to this DMM 6500. They're compatible, and you can still use the same scanner card as you had on the old one. So you will get a new graphical user interface, which is like a touch and sweep and touch screen, and just works perfectly. I love it. And then the 2700 and 2701 was replaced by the DAQ6510, and you can still reuse all your existing switch cards. So it's a great opportunity for you to look at really a modern, nice, fun instrument. And it gives you so much more dimension in your measurement. It's so easy to set up a measurement. It's unbelievable. We go to the next slide here. I mean, 65 can make your job easier. There's a lot of things we can do, multi-scannel. I will move through these slides a little bit. Both the DMM and the DAQ has this kind of oscilloscope functions where you at 1 mega sample, you can sample a device, turn off, turn on power to get those rare events of transients, for example, which is nice. I will try to show you that as well. I mean, from the user interface and front panel, you can pinch and zoom and look, and you get all the measurement as you want. The test speed here, you can also put everything together and build your own kind of small tester with the source meter, DMM, and some of these can use LAN, LXI. There's also TSP scripting, which I will cover in another episode. But TSP is actually inside of all the instruments. There's a small PC where you can upload your project and tell that unit to control other instruments. So instead of sending all the commands, back and forth, you will send one command: start my program. It will run through that, and when it's done, it will dump you all the results. Really nice. A lot of people using it. I mean, legacy test system, yes, we do that. We have a code emulation for 2000, all for the Keysight. The DAQ is really nice. I mean, it's really easy to set up what kind of measurement you want to do, and you have them immediately on screen on your DMM or DAQ. You can see the temp, if you have a temp chamber, for example, you want to monitor something, you will see that live. I mean, you have this. I will try to find the slide I want. One of the things that is good instead of the cost is a 2-year specification, so you don't have to calibrate it. We reduce the calibration cost by half, which is really nice. I will move a little bit, sorry. And this is the back. This is probably one of the interesting, there's, accessory and communication card. So the communication card, if you look at this on back side, it's like LAN and USB. Some of you guys still, where's the GPIB, where's the RS-222, where's this, and where we still support it, but you actually have to buy a communication accessory module to push in. It's the same when people ask me, where's the TSP? I don't see the TSP link that I talked to you earlier about. It's also an accessory for the communication box. And you can see the difference there. On the DMM, there's one slot for that's a 2000 scan slot, and the other one is all the 7700 slots. In terms of these communication options, there's the TSP link I talked about, there's the GPIB and RS-222, but most people tend to try to get away from this. The TSP link is a different story. It's needed if you want to build a really rapid and simplified test system. You're going to like it. The other one, the GPIB, yeah, some people still have GPIB if they're an old standard, and RS-222 is but it has the digital input-output, same as the TSP link, so you can use that for other stuff. So this is, touch test event portfolio for all your needs. It's the 6500, it's DAQ6510 and DMM7510. So this is 5 minutes are gone, and I try to shorten this one. So the next episode, I will show you how you do it. So here we are. This is, I have them under my knee. Oh, here is one. They're quite heavy. So this is one of the boxes. This is the 6500. This is how it looks like. And this is how it looks on the back, as I show you. I'm not going to run this instrument today. I'm going to run another one, which I have over here by accident. Rich, here it is. This one is the funny one. So if you look at this one, it's the DAQ6510. Brand new, just given to me by Demopool. And here's the back of that one. So let me try to get this working. I'm not sure, but let's see. And in as well here, I have this card, which is a slot card. If you've never seen, I can actually open one of these. I should be able to open like this. This is how it looks like inside. Here you can put all your, if you want to measure temperature, voltage, whatever you want to do, and you put them out, and in here you plug the cables out. So this is a 20 channel card. Hopefully I can get back together. And then I'm just gonna tighten this up a little bit like this. This goes in the back. I will try to get this in the back. And I had some issues. There it is. I need a power cable. It's in. And I'm gonna push the LAN cable in as well. So you have the LAN. Okay, so now we can power it on. Oh, you see it's Keithley. It's quite silent instrument, by the way. So what I'm going to do now is just show you how I installed the IP address so I can run the program from the background. So it's booted up. It's quite rapid. And here's the menu. There's a menu. Maybe I can take the camera like this. Here's the menu. I press menu and I press communication. I go to LAN, and this is where I put the manual. So I put it into manual. And I just change the IP. You can go in and change the IP. In this case, it's number 11. Okay. And apply settings. And that will update everything. And from that point on, it's very, very easy to run it. So I will leave this camera on for a while, if I can get it in stable. And you can see the LAN is. So from the home button here, you can do everything you want. You can whatever. And from the menu, you can have a graphical view if you want to do that. And there's an apps also. And these are apps you can build yourself, but I'm not going into that. I will just press the home key like this, and we're gonna start playing with what I really like, Kickstart. And for this project, I'm gonna use the standard probes that is coming with the DMM. I'm gonna take my car, which is a remote control 2.4 gigahertz car with really lousy batteries, and I also have a remote control. And I'm going to plug this together, and let's see if I can figure this one out. So the first thing I do, I plug this into there. A little bit of plugging. And hopefully you will be able to, I'm not sure if you'll be able to see my car or not, but I've put it down a little bit. Here's the car. Not great, the camera. And I'm going to monitor and just, like this one. I'm going to put it in. And hopefully this will hold as well. I'm not sure. But you can see that there's 1.4 volts. Okay, let's move back to the generic, this one. And here is the thing. This is my DAQ. So I can double click on this one, and it can ask me to be a DMM or data logger. I will be the DMM in this case. I just press OK. And I measure from the front, fine. Measure count infinite, I can just run. So I'm just a normal DMM now. Thing is that you have a table which will be populated and a graph. So this is just looking at the voltage over time, which is completely fine. So my test word today is looking at, oh, of course, I removed it now. So I'm looking at what's happening when I'm powering on this car. I will have this one like that, probing back again. And this one at that. That's the 4 volts, yep. And now we'll turn this on and on. You can't really see it there, but we're going to stop this one and start a new measurement again, so you can see it a little bit better. And I will probe. Let me see which one I will probe. I can probe this one and this one. That should be, if I could have like this. And I run again. So here you see the voltage is running fine. I will turn this little bugger on. It's on. And you can see some strange behaviors up here. And now we will turn my remote control sensor on. And I will try to, oh, of course, the cable fell off. We're getting it back again like this. And I will run. You can actually see how bad the batteries are, and then at one point it will just die. I can hear a car running. If I stop this one now for a moment, and let's think what we have. I can go back here and auto scale from the beginning. So this was on, this was it, and there's a zoom box here, and I really like this one. And in the beginning, I saw there was something funny going on. This is actually what I call, when the RF is on. So it's kind of looking at the RF coming in. And it's also requesting the ID. The 2.4 actually communication says, here's me, this is the car, this is it. So you can run multiple cars with one, multiple cars at the same time. And this is actually the transmitter saying that I'm here, this is me, this is me. And I can further zoom this one to look at this. And you can see it's just, the batteries are not that great, but you can see each of the individual pulses here going. Going back to this one, this is where I dropped the contact. I put it back and I dropped it and put it back. And here I start driving my car. So we were zoom into this part over here. Zoom into this part over here. I can just do it like this. And you can see, it's getting worse and worse. So you can see it's a flat line. Anyway, it's very, very simple. Very simple. And now I will go and I will look at the... we can close this one. We will look at how you worked with matrix. We delete this one. We can redo it again if you want to. I go in here and I say data logger, okay? It will open up, hopefully. And you see that it asks me to put in some channels. So we can use channel 1 and channel 2 and channel 3. A function should be DC voltage, for example. And I can apply them to entire group, saying that range, auto, and 1 LPLC. Okay, that seems okay. Save settings. And now I will press play. This will probably say, no. It's a warning sign. Instrument terminal set up front. Set the terminals to rear to run the data logger. Okay, there's a button in the front of the scope. And I will press that one, and we will run again. Oh, you can hear, and here's the table. And here's the graph. And of course, it's just all over the place. And I stop. So I take 100 steps. This was one, so this is kind of a noise anyway. I can also go in and change whatever I want, and I can test a lot of cool stuff with this one. It's just working brilliantly. In this case, we had the scale, and the scale was up to 1 volt. And this is probably what you can see. Of course, I didn't have anything to connect this time, but I mean, and if you save this project, you can always go back and look at min and max. It just works perfectly. The last thing I want to do is set up a thing here when I try to monitor in the full voltage. Double click this one, and we're gonna do it as a DMM. Yes. See here. And we should have it in front. Thank you. I don't know what's happening there. Front. We do it again. Cancel. Let's try play. it's front now. Stop. So it's the front, and here we can say also to use the digitize voltage. And in trigger mode, I should have an analog window, and bound should be like 5 volts, and maybe 3.5 or 3 volt, 3.5 volts. And when it leaves this area, I should trigger. So I run this one now, run. Of course, nothing happened. I need to turn this one on and off. And there it is. And now I capture this one with the graph, and you can see that it's nothing really good happens here. We try it again. So what did I do? Maximum, not 100. I just had 100 when it fails out of this. So we do it again. I'm probing. I press run. It's ready. And now I put it on. And it should be done. Yep. So I can stop. And I can look at the graph again. So this is the graph of me capturing like 200 milliseconds of a part when it went down below 3.5 volts and what's happening on the way up. And you can really see how quick but we are between the sample points. You can see. So it's not the best demo for this one, but at least this is what I have. I hope you enjoyed this video. Talk to you again soon. But try Kickstart, try the DAQ, ask your local rep, ask Tektronix or Keithley Direct. It's just amazing. Thank you.